Deciphering the secrets of the Sun. In August 2018, NASA launched the Parker Space Probe in a bid to better understand one of the greatest mysteries still puzzling researchers about the Sun: its corona. Let's dive into what researchers recently discovered. What is the Sun's corona? The corona is the outermost atmosphere of our Sun and is difficult to see without the assistance of instruments. The corona is visible during a total eclipse, but this isn't the mystery that's been baffling astronomers. Investigating temperature differences. The Parker Space Probe was designed to investigate the temperature difference between the Sun's photosphere, the big yellow part that we can see, and its corona, which is vastly hotter than the photosphere. How hot are the photosphere and corona? According to Earth's sky, the visible part of the Sun sits at around 6,000 degrees Celsius, 11,000 degrees Fahrenheit, while the Sun's corona hits temperatures that are as high as 1 million degrees Celsius, 1.8 million degrees Fahrenheit, or higher. It's like switching on a light bulb. And the bulb is warm to the touch, but the air around it is 1,000 times hotter. Space.com wrote about the phenomenon, and researchers have no idea why there is such a huge temperature disparity. What we do know is that the corona can't be heated through a normal process of heat transfer, since this would end up violating the second law of thermodynamics. A cooler Sun surface can't heat the warmer corona, so what's causing the heating? Scientific speculation. For a long time, scientists have speculated that the corona was being heated through a process that involved the Sun's magnetic fields that play a vast role in the Sun. However, this has yet to be proven. But this theory does make sense. A monumental discovery. During its sixth flyby of the Sun, the Parker Space Probe discovered strange flips in the Sun's magnetic field as it approached the star. These later came to be called switchbacks, and they could explain the temperature difference between the photosphere and corona. Explaining switchbacks. A switchback starts in the turbulent photosphere, where plumes of plasma constantly well up to the surface and slink back down. Sometimes, regions of intense magnetic energy can form, where many field lines tangle up on each other, Space.com noted. Creating gigantic kinks. Some of these fields are straight, pointing away from the Sun. Others loop back to the surface in the shape of a giant horseshoe, Space.com added. When these fields bump up against one another, they can disconnect and reconnect, creating gigantic kinks. The kinks are switchbacks. The kink in the magnetic fields is what is the switchback, and this process can lead to an immense amount of energy being delivered to the corona, which is what astronomers now think is the most important way the corona is being heated. Explaining the Sun's greatest mystery. This research is more than just an interesting and possible answer to one of the biggest mysteries about the Sun. Figuring out what is causing the corona's high temperature is also important for helping us understand phenomena on Earth. Why this research matters. The Sun's magnetic fields play a big role in space weather, those huge plasma storms that get released from the Sun and affect things like humanity's satellites, spaceflight, and power grids all across the world. Helping humanity plan for solar storms. The more we understand about the complex role of magnetic fields throughout all regions of the Sun, the better we can predict and plan for solar storms of all kinds, Space.com explained. The Parker Space Probe's mission. The Parker Space Probe will complete 24 orbits of the Sun before its mission is over, and has already flown 7 times closer to the Sun than any spacecraft before it, according to NASA. A resilient and useful space probe. At its closest approach, the Parker Space Probe will come within 3.9 million miles, 6.2 million kilometers, of the Sun, which it will be more than able to handle, since the probe can handle temperatures upwards of 2,500 degrees Fahrenheit, 1,377 Celsius.